So in this film we're going to look at silver soldering, and we're going to use silver solder, some flux, and we're going to solder up our little copper practice pieces. We're going to use this silver solder, and really they are sort of strips of silver, but they have a little additive, just a little bit of zinc, which reduces the melting temperature of the metal so that you can join two pieces together by just melting the contact surfaces for a split second, and they fuse together, so it becomes one piece. It's not like a glue at all. The metals merge together and becomes one piece. The reason for the two different strips is, this is called hard silver solder, and it's got a melting temperature of about 170 degrees. And this is called easy silver solder, and it melts at about 680 degrees. The reason for that is that if you were doing multiple soldering joints, then you could start off with the high melting temperature, and do subsequent soldering joints with the easy silver solder, so that the whole thing doesn't fall to pieces while you're soldering. We generally use the hard silver solder mostly because it matches the silver colour better, so you can get an invisible join. We're going to prepare the metal for soldering. So there's two main rules for soldering. The first rule is that it's got to be a really good join, no gaps, and it's got to sit nicely together. If you're trying to force things together, it tends not to work very well. What we've got is a very simple flat piece of metal and a bit of curved wall that we're going to solder together. So the second rule is that it's got to be a really good clean surface. And the edge of this little wall that we're going to solder on is quite easy to clean, and we use a file just to brighten up this edge, and it also makes it so it's nice and flat. And with the big files like this, you always push them. They cut on the push. If you go backwards and forwards, it's going to gum up the file. So just always push with the file. In our case, we want a nice clean surface. And now it sits on there, and we can't see any daylight going through, so that's ready for the next process. The next step, we've got to clean this bit of metal. We could file it, but we might have a nice texture or some sort of detail on that we didn't want to mark. So we're going to use toothbrushes and pumice powder, and you can see by running the water over it that there's so much grease on the surface of the metal that the water won't stick to it. We're going to wet our little toothbrush and just dip it into this pumice powder. And pumice is a thing that you use for getting rid of hard skin and things, but it's in powdered form. So it's a fine abrasive powder, and it's great for cutting through grease and dirt. And we just hold it by the edge and give it a good scrub, and it does abrade the metal, but it's so fine scratches that you can soon polish it back up with polishing, which we'll look at a little bit later. So once you've given it a good scrub, hold it by the edges, because there's always a bit of grease on your fingers, and then if you run it on the tap, then you can see that the water sticks to the surface now, and that's a good indication that it's nice and grease-free. For this step, we've prepared the metal for soldering. We're going to set up the piece ready for soldering, and then do the solder. The first step is to make sure that the metal stays clean. And when we were annealing in the last video, we heated the metal up and it turned black, it oxidized. And what we've got to do, we've got to stop that from happening. And how we do that is we use a thing called a flux. And what a flux does is protect the area and the solder and keeps the join nice and clean. In jewellery, we use a borax flux, and in this case, this is a borax cone. And what it is, a borax is a mineral, and it's used in cleaning fluids and washing powders and things. But in jewellery, the properties are, as you heat it up, what happens is the borax creates like a glassy coating onto the surface of the metal, and that creates a barrier to the atmosphere and the sort of oxygen in the flame, so it stops the metal from oxidizing. It comes with a little dish, and we put a bit of water in and we rub it round, and it creates like a milky paste. And it doesn't want to be too watery or too sort of pasty, just sort of creamy. And that's ready to paint on the surface. So we've cleaned the metal, and we've put the metal on a raised brick so we can get the heat all the way around. So for a start, we paint the borax onto the surface of the metal, and you can never have too much borax, because once you've completed the soldering, it can go in the pickle and the borax will be dissolved away by the acid. And because this is a liquid, we don't have to worry about painting the edge here in this particular join. We can just sit it into the liquid flux. Other soldering, you may have to paint all the joints. So, and then we're going to use our little solder strip, and we're going to use the hard solder. And what I've done is cut a little strip off, and I've cleaned it with the pumice powder so it's nice and grease free and dirt free as well. And then we're going to cut the strip, which is a bit tricky, but you can get pliers that do it for you, but we're just cutting them with the shears. And we cut like little fingers, and because it's a really good join, we only need a very small amount of solder, and we just cut across the little fingers, so it just gives us some small pieces called palions, small pieces. So we've fluxed the metal, and then with the brush that we use to paint the flux on, it's a bit fiddly, but we pick them up. It's a sort of scooping effect, and by doing that, then we're coating the little pieces of solder with the borax flux as well, and we'll put those anywhere we like. I think one piece would be enough, but it would be embarrassing if it didn't work, so we'll put 2 pieces on, and then we'll be able to see the solder run along the join. So we've fluxed the piece, we've put it in position, we've got it all nice and settled. We're not forcing it together or anything. If you start forcing a solder joint together, then it just makes it harder work. So try, and whatever joint you're going to do, make it so it sort of wants to be joined, and so you don't have to force it together. This is called a solder pick, and it's just titanium wire with a pointed end, and it's great for moving little pieces of solder as things are heated up. I've got our tweezers if we need to pick anything off, and these are called reverse action tweezers. You squeeze them to let go, and they're great for just holding things quite gently, but they're opposite to the tweezers, so you squeeze those to let go and you nip those. But so they're ready, and our solder pick we might need. So just make sure everything's in place, and then we get a nice little flame. And with the flame, it has a little blue sharp point with the flame, and the point of that flame is the hottest bit. If you go too near, it gets colder, At the point, you can see that solder pick heats up quite quickly, but if you move towards it, cools down. So don't go too near with the flame, basically. So as we go along, we'll keep the flame moving, and you can see the water evaporates and it leaves a sort of crystalline coating on the surface. So what we've got to do, it's very easy to heat up the wall, so we've got to keep the flame moving so we can heat the background and the wall at the same time. The solder will run to the hottest bit, so if we had the wall too hot, then it would run up the wall. If they had the base too hot, it would run along the base. So we've got to get that happy medium. The solder's got to be touching both bits, and as you see it gets to temperature, you can see the solder running along the seam. And if you can sort of draw it along as well, and so you can see it shimmering perhaps in the light. Once it's run all the way along the join, then just take the heat off and it'll solidify. So once it's cooled down a little bit, then just quench it straight away in the water, and we can see that the solder's run all the way round on the inside, and because we've got the heat perfectly right, and you can see this sort of glassy coating the borax has left, and that's protected the metal. And if we wanted to get rid of that, then we could put it into the pickle, and the acid would eat into the pickle and clean all the metal up. You can see the underside has sort of oxidized a bit. You see all this black, it's oxidization and on the wall, but where we've put the borax, it's kept the metal nice and clean. And we can sort of bend this, and it's so strong that you could hammer it and bend it, and it would stay together until it became work hardened. And so that's nicely joined together.